In this video, we will learn how to look for information in an output file. In one of our last videos, we have seen how to run a calculation, and we have run the optimization of methane molecule. And I told you at the end of the calculation, you may get either log file only, or you may get log plus checkpoint file, depending on your information that you gave to the software. If you opted to save the checkpoint file, you will get the checkpoint file. Otherwise, you will get only the log file. Under default setting, you will get the checkpoint file as well. And here are the input file, log file, and checkpoint file. Let's say we open up the log file. We go to File, and we click Open. And in Download, we look for the output file, which is methane optimization.log, this one here. When you're opening this file, you need to make sure that you check this one here, which is saying read intermediate geometries, because it will tell you, or it will show all the geometries which were drawn by the software during the process of optimization. So it will tell you how many steps are taken for this optimization process, and you can also retain these settings. So what happens here, when you do this, you check this box here and you retain setting. It means every time you open the log file, it will open up the intermediate structures. So now if I open it, if it opens up without any error message, it means it is run successfully. And now you can see here it says 3 of 3. It means this optimization took 3 steps to optimize from your given structure. The number of steps taken are quite small in this case because this molecule is only single carbon atom and 4 hydrogen, small molecule. That's why it took less time. If the structure is getting big and big and your input geometry is not close to the equilibrium geometry, then the number of steps are increasing. Ideally, if your structure is optimized in less than 20 steps, it means your input geometry is really good. If it is going to take more than 20 steps, there may be 2 reasons. Either the structure is not present on a steep potential energy surface, or it may be present on a shallow surface, what you can call. Alternatively, your input geometry is not really good. So if you go to Results and look for optimization, it tells you that how the energy was changing during the process of optimization. You can see in the first step, going from structure 1 to structure 2, it dropped the energy, and from structure 2 to structure 3, it was almost like constant. We will see this theory in a later lecture. Now, what to look for in the results? Generally, if you go to the summary, it gives you the summary that you ran optimization. Calculation method was restricted Hartree-Fock. The basis set was 3 to 1G. Charge was 0. Spin was singlet. And solvation, you did not apply any solvent model, so solvation was none. And here you have the energy. Now, this is the energy of this methane molecule in Hartree units, 39.976878. And you should bear in mind that 1 Hartree is equal to 627.5095. So it is 627.5095 kilocalories per mole. Now this absolute number here is meaningless because it involves all the energies like energy, kinetic energy of nuclei, kinetic energy of electron in carbon and hydrogen, their electrostatic interaction. So this absolute number is not useful whenever you're going to compare the number in comparison to some other similar structure may be useful. For example, if you're talking about the conformational analysis, then these numbers may be useful, but for a single molecule, this number is meaningless. You just need to make sure that this is optimized successfully. We can also look for this information in the log file if you open it up in the Notepad. Let's say if you open in the Notepad, you will see it's quite complicated looking, but in reality, it's not really complicated because at the beginning, it gives the Gaussian different version, which were developed over the last 40 years. So starting from Gaussian 82, 83, 86, 88, 90, 92, 95, 98, 2003, 2009. Then here, if you scroll down, there is some warning. And there's quite an interesting warning here that this program may not be used in any manner that competes with the business of Gaussian because it's a paired software. Then here, down here, you have citation for this version on which you run the calculation. For example, if you run calculation on Gaussian 09 Rivian A02, then this is the complete citation that you should put in the manuscript if you're going to publish the results. Then down here, it gives all those commands that you gave. You gave the command of nproc shared, like to use 4 processor in shared memory. 50 megawords memory should be chosen or should be used. %check path. Then we have optimization, RT4321G. This is the root line. And down here, it starts some number which are not really meaningful to you. If you further scroll down, you will get a lot of data. I don't ask you to read through all these data, but just you need to pay attention to a couple of things here. If you keep on scrolling down, you can see here, this is the energy which was plotted in the first step. So SCF done, energy is equal to minus 39.97640. That's the first step energy. If you further scroll down, you will see that it will show in the first step, these are the convergence criteria. You can see there are 4 parameters: maximum force, RMS force, maximum displacement, RMS displacement. And here, this is the value calculated for this particular geometry, and this is the threshold. If the value calculated for that particular geometry for any of these parameters is less than the threshold, the convergence will be yes. Now, at this point, this value is greater than this one, this value is greater than this one, this value is also greater than this one. So for all of these, it is no, there is no convergence. It means the convergence criteria are not met. So if convergence criteria are not met, the software updates the geometry. So it means it got a new input orientation, new geometry here. Again, it does the same process. If you keep on further scrolling down, you will see that it prints energy for the second step. And now let's see if it is converged or not. So you can see only one parameter is converged, which is the RMS displacement. The other 3 parameters, they are still not converged. So if they are not converged, it means the software will update the geometry. So it gets a new input orientation, a new geometry, which is given by these Cartesian coordinates. Again, it does energy calculation, and again, it calculates the convergence criteria. So now the given structure meets all the convergence criteria. The actual values are less than the threshold values, and you get yes, 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 and yes. This is one of the rare cases where you have absolute 0 value for maximum force, RMS force, maximum displacement, and RMS displacement. Generally, it never reaches 0 for all of them, even it never reaches absolute 0 for any of these parameters, leave aside all of them. So this is small molecule. It happens so that all of these values are 0, 0, 0, and 0. Now the convergence criteria are met. This structure is considered as optimized, and once it is optimized, it prints certain values here. So you can see it prints the atomic charges. It also prints condensed to atom all electrons. And down here it prints dipole, quadrupole, then octupole, hexadecapole, all these multipole values are given here. Chemists are generally more interested in this dipole moment. And you can see in this case, the dipole moment is 0. Dipole moment along x-axis, along y-axis, and along z-axis, they're all 0, so their total should be 0. Most of the key information in any output file are in this last paragraph here. It gives a summary. It says that this is the name of PC, this is the type of calculation, which is optimization, this is the method, basis set, the formula, like it is carbon 1 for hydrogen. Again, the name of the PC on which calculation is run here, the date, and root line here, title card, and then the coordinates of molecule like carbon coordinates, hydrogen coordinates, and so on. Then it gives the version on which calculation was run. And then it gives here energy, which is HF energy. So whenever you see HF is equal to some number here, this is the number which is the energy of the molecule. And this number should match with the value that you see if you go to summary here. If you go to results and go to summary, and now you're this number, 39.9768, 39.9768, 776 is rounded off to 78. So these two numbers should match. So whatever the number that you get from this Gauss view can also be obtained from the Gaussian log file. And beyond this, you have dipole, quadrupole, and that's it. The good thing is at the end of this log file, you see sometimes beautiful quotes there. And down here, you can see how much time is taken. The time taken is 13 seconds. And finally, it gives the normal termination of Gaussian. If you see normal termination keyword, normal termination word here, it means your job is run successfully. If it is not run successfully, you will get some error message here, and that error message also shows up when you try to open the file in Gauss view. And it says it is normal termination, and it was completed on Sunday, February 25th at this time and year. So now I hope you have learned how to look for information in the output file, both through Gauss view and in the log file while using Notepad in the text form.